Presentation, we are going to discuss about shared data problem. Shared data problem is a common problem which exists in all the systems. So what is this shared data problem, how it happens, how to overcome this shared data problem, that we are going to discuss it now here. So with respect to real-time operating system, with respect to Simon author book, the shared data problem is discussed by having the petrol bunk as an example. Let us take the petrol bunk. In the petrol bunk, all the petrol tanks in the underground. So it is mandatory for us to monitor the petrol temperature, not to become explosive. So petrol tank need to be monitored continuously. Exactly speaking, the petrol tank temperature need to be monitored continuously for the safer petrol bunk operation. So to monitor the petrol tank temperatures, two temperature sensors are present in the underground tank. So hence this problem or this case study is called as underground tank monitoring system. Okay, so the shared data problem is going to happen in underground tank monitoring system as we see here. So there is a temperature sensor T1 and there is a temperature sensor T2. Two temperature sensors are kept in the underground petrol tank, and when we write a code, we are using the variable, right? temp, temp1 is a variable which is used to get the temperature 1, and temp2 is a variable which is used to get the temperature 2. We can use this function as read temp. Read temperature is a function. So read temperature is a function which reads the temperature, which is having the highest priority function. Let us assume like this. And there is something like compare temperature function. Compare temperature function is a function which compares the temperature. So compare temperature function, what it does, if temp1 equal to temp1 is not equal to temp2, if the temperature 1 is not equal to temperature 2, it will switch on the fire alarm, because if both the temperature is not equal, then it may switch on the emergency alarm. That is the condition. So you are checking for temperature 1 is not equal to temperature 2. If both the temperatures are not equal, then we have to switch on the fire alarm. You have to switch on the fire alarm. Fire alarm equal to 1. Else fire alarm equal to 0. Something like that. We have written the code. Let us assume this is the code that we have written. So underground tank monitoring system, two temperature sensors. There are two functions. Read temperature function which reads the temperature, which uses the common variable temp1 and temp2. The same temp1 and temp2 are used in the compare temperature function, where two temperatures are compared, and when both the temperatures are not equal, fire alarm will set, else the fire alarm will become 0. So in this particular functions, there is a possibilities of shared data problem. Why? Because the temperature data temp1 and temp2 are shared between the two functions, read temperature function and compare temperature function. Read temperature function is having highest priority and compare temperature function is having lowest priority. Let us say, for example, so even though this particular C program, if it looks like a single line of code, but when this C program is converted into assembly language program by the cross compiler, the comparing the two temperature means, in an assembly language program, comparing two temperatures cannot happen by comparing two temperatures. One of the variables should come to the accumulator. So the assembly language program might be MOV A, temp1. There may be MOV A, temp1, and XOR operation is a good operation to check the similarity. Hence XOR of A with temperature 2, and if the temperature is not equal, that means if jump 0, okay, if the conditional jump, so jump 0 means both the temperatures are equal, safe, jump to the safe label, else switch on the alarm. So switch on the alarm means set bit alarm equal to 1. Set bit alarm, something like that. Okay, so one thing what we have to understand here is this particular compare statement. If temp1 is not equal to temp2, looks like a single line of code in the C program, but when it is converted to assembly language program, the single line of code is becoming three particular lines in an assembly. So where there is a possibility of shared data problem. Let us see one example. Now let us assume the temperature 1 is sensed. So let us say temperature 1 is 20 degrees centigrade and temperature 2 is 20 degrees centigrade. So the read temperature function reads the temperature as 20 and the temperature 2 as 20. And the compare temperature task compares temperature 1 is not equal to temperature 2. So how it compares? So the temp 1 value will come to the accumulator. So accumulator will be having 20 and the accumulator value is XORed with temperature 2 and temp 2 value will be also 20. So both are compared. When they are compared means you do the subtraction operation. So the result will be 0. Why? Because both are equal. XORing two equal numbers will result in 0. So because it is jump 0, it will jump to safe. In the safe, it will clear the alarm. Something like that. The code has been written. Okay. After some time, the temperature T1 has updated to 21 and T2 was updated to 22. Temperature sensor T1 measures 21, temperature sensor T2 measures 21. The read temperature task reads the temperature as 21. The temperature 2 is updated as 21. And while comparing, temp 1 is not equal to temp 2. Again, here, temp 1, the accumulator value will become 21, which is XORed with temp 2, which is 21. So both are equal. So jump 0. So clear alarm. This continues. So when it is continuing, right? Now the temperature has become 24. Say for example, now the temperature T1 measures 24 and the temperature T2 measures 24. So now while executing compare operation, if temp 1 is not equal to temp 2, here in the assembly language program, move a comma temp 1. So a is already 24, a is 24 and temp 2 is also 24, jump 0, etc. Then it keep on doing this. MOV a comma temp 1, XOR a comma temp 2, it goes on like this. Now while executing MOV a comma temp 1, after executing MOV a comma temp 1, that means this is 24, and because read temperature is having highest priority, here if interrupt comes, let us assume at this point interrupt comes means after updating temp 1 value to accumulator, which is 24, and the interrupt, because highest priority task is read temperature task unblocks, and because of that the interrupt comes here after executing this first line. After updating temp 1, before updating temp 2, if the interrupt comes means it goes to the interrupt service routine. In the interrupt service routine, let us assume the temperature 1 is updated to 26, temperature 2 is updated to 26. Both the temperatures are equal. Temperature 1 is 26 degree, temperature 2 is 26 degree. Temperature 1 has updated to 26 degree, temperature 2 has updated to 26 degree. And after returning from the interrupt service routine, it's come back to the compare temperature task. In compare temperature task here, what will happen? Already the accumulator will have 24. And the next instruction to be executed is it executes this line, go to the ISR, and it come back here. And here it is XORing the accumulator content with temp2 content. What is temp2? 26. So temp2 is 26. What is accumulator content? Accumulator content is 24. But the original temperature 1 and temperature 2 both are 26. But here the accumulator content is 24. Temperature 2 content is 26. So both are not equal. Even though both the temperatures are equal, before updating temp 2, the interrupt service routine is being called. Hence, the earlier old data of temp 1 is compared with the new data of temp 2. Unfortunately, both the data are different. Hence, even though the temperature 1, temperature 2 are equal, but while comparing, both the temperature looks like they are different. 24 is compared with 26, and the XORing operation will not be 0, and it will switch on the alarm. So this is the shared data problem. Even though both the temperatures are equal, but the alarm will switch on because the interrupt happens between these two instructions. Because of that, shared data problem has occurred, which is a big disaster for a C programming or embedded system programming. This has to be prevented. That is what we are going to discuss in detail. How to prevent this? Here we can disable interrupt. So here we can disable interrupt means IE should be 0x00, and here you have to write IE should be 0x82 or something. So disabling interrupt here wherever there is a shared data problem may come, and enabling the interrupt after this critical section means shared data problem can be prevented. Shared data problem may only exist when the interrupt comes in between these two lines. But in the C program it looks like a single line, but here it is a two line. So temperature 1 is a global variable, temperature 2 is a global variable. These two global variables need to be shared between two functions. One is read temperature function and another is a compare temperature functions. Because these two variables, temp1 and temp2, are shared between these two functions, there is a possibility of shared data problem, and this has to be prevented. To prevent this, you have to disable interrupt and enable interrupt in the conventional C program. But in the real-time operating system, we use semaphores, which is one of this special feature which prevents the shared data problem. Okay, so with this discussion, with this case study, we have understood what is shared data problem and how it happens in the underground tank monitoring system with respect to David E. Simon, a embedded software primer. Okay, so shared data problem is major problem which has to be addressed. Now we have understood what is shared data problem. In the next presentation we will talk about how to prevent the shared data problem, and we can see one example also by executing some program in the Kyle IDE. Thank you.